Okay, so today we're diving deep into the world of metal casting.
Mm-hmm.
I've been going through all the material you sent over,
Mm.
and honestly, I'm impressed. Clearly, you know your stuff. I mean, it's clear there's so much more to it than just, pouring molten metal into a mold and,
Yeah.
and hoping for the best. From what I see here, there's a whole spectrum of techniques.
Right.
Everything from like the classic sand casting to like really cutting edge stuff like vacuum die casting.
Exactly. And each technique kind of has its own like strengths and weaknesses,
Yeah.
making it ideal for certain applications.
Yeah, that's what I'm seeing. We've got gravity die casting, sand casting, and a whole like bunch of these pressure-based methods. I'm excited
Yeah.
to unpack this. Where should we start?
Well, I guess we can start with the most straightforward gravity die casting.
Okay, so gravity die casting, molten metal, gravity. That was pretty self-explanatory. What's the big deal here?
Well, it's simple, but it's effective. The molten metal flows into the mold. It's naturally pulled by gravity and then
Hmm.
solidifies. And what you get are parts that are really strong and dense with fewer flaws than other methods because the metal kind of like settles in
Wow.
naturally.
Huh. So it's all about just letting nature take its course to get a more solid result. I like it.
Yeah.
But where would you actually use this method? Like what kind of applications?
Well, imagine, you're building a large machine, something that needs to withstand a lot of stress, a lot of pressure.
Now,
Gravity die casting would be perfect for creating like those crucial, load bearing parts. Think about like those big heavy duty gears you
like
see in industrial machinery, for instance.
Oh, okay. Yeah, you wouldn't want those failing under pressure. Okay, that makes sense. So let's shift gears, no pun intended, to something I feel like we've all seen at some point. Sand casting. I'm picturing like that classic image of molten metal being poured into a sand mold, maybe from like a school science class or something.
Right. Exactly. Yeah. And it's more than just like a classroom demonstration. Sand casting has been used for centuries and it's still incredibly relevant today, particularly for like larger, more complex shapes that
Yeah.
you wouldn't be able to make easily with other methods.
It seems pretty simple though, right? Like
Yeah.
sand, metal. Is there a trick to it?
Well, the art lies in crafting the sand mold itself. Like it needs to be packed
Okay.
perfectly so that the molten metal fills like every nook and cranny.
Gotcha.
If not, then you risk imperfections in the final piece.
Ah, so there's a real craftsmanship element to getting it right.
For sure.
Interesting. Now, things seem to get a bit more like high tech when we move into the world of pressure-based casting. And we've got a whole range here.
Mm.
Low, medium, and high pressure. What's the difference and why so many options?
Well, I guess you can think of pressure as a way to kind of fine tune the process and ultimately the
Hmm.
properties of the final piece. Medium pressure casting, for instance, is it's like the all rounder, if you will.
Okay, so like a jack of all trades. When would you use that method?
Exactly. It strikes a really good balance between speed and precision,
Right.
making it incredibly versatile across a wide range of industries.
Okay.
One of the key advantages is it results in a reduced porosity.
Okay, porosity. For those of us who aren't, metal casting experts, what does that mean and why should we care?
So porosity refers to the tiny holes or voids
Right.
that can form within a cast part.
Okay.
The fewer holes there are, the stronger and more durable the part is. So medium pressure casting helps, minimize these imperfections.
Got it. So more pressure equals fewer flaws, better final product.
Well, not always. Low pressure casting, while slower,
Yeah.
is actually ideal for producing those really massive,
Yeah.
heavy-duty components that need exceptional, strength.
Okay. Low and slow wins the race when it comes to certain applications. What comes to mind when you think low pressure casting? Like, give me an example.
Um, well, imagine like the engine block of a giant cargo ship.
Okay, yeah. Yeah.
I mean, you're talking about a piece of metal the size of a small car.
Oh, wow.
It has to withstand immense pressure and stress
Yeah.
for,
Yeah.
years on end. Low pressure casting is how they create those incredibly strong and durable parts.
Wow, that puts it into perspective. Okay, now high pressure casting, that sounds like things are getting intense.
It is. High pressure casting involves forcing molten metal into the mold with, well, extremely high pressure.
Okay.
The benefit is that the mold fills incredibly quickly and the metal solidifies almost instantly.
So time is of the essence here. But what's the advantage of that super fast process?
Well, you get parts with incredible precision and exceptionally smooth surfaces.
Gotcha.
This is essential for things like intricate aerospace components
Right.
or the tiny, delicate parts found in like electronics. Think about like the fine details on your smartphone's casing, for example.
Okay, yeah, I'm starting to see how the method really dictates the application.
Uh-huh.
But hold on, we're not done yet. We still got a few more specialized techniques to cover, starting with squeeze casting,
Right.
which, it's not just casting, it's like giving the metal a workout.
That's a good way to put it.
So squeeze casting takes things a step further by applying pressure to the metal, even as it cools and solidifies.
Yes.
So it's not just about filling the mold, it's about shaping the metal under pressure.
Yeah.
What kind of result does that, get you?
Well, this workout, so to speak, creates parts that are incredibly dense, strong, and wear-resistant. So think about components that need to withstand constant friction or heavy impacts.
Okay, so anything that needs to, stand up to some serious abuse.
Right.
Now, this next one really caught my eye. Semi-solid die casting. Partially solidified metal? That sounds kind of counterintuitive.
Yeah, I can see why I'd say that. But using metal in that in-between state, neither fully liquid nor solid,
Right.
is the secret to achieving both high strength and low porosity.
So you're getting the best of both worlds. What kind of parts benefit from this unique approach?
It's ideal for high-performance engine components.
Okay.
These parts need to be strong enough to withstand the forces inside an engine, yet also free of, imperfections that could lead to failure.
Yeah.
Semi-solid die casting kind of delivers on both of those fronts.
Fascinating. Okay, last but not least, we have vacuum die casting. This one sounds straight out of a sci-fi movie, sucking out all the air to get the perfect cast. Really?
Precisely. By creating a vacuum within the mold, you essentially eliminate any trapped air.
Okay.
Which is, a major culprit for imperfections in the casting process.
So it's all about creating a controlled environment.
Yes.
For the metal to solidify in.
Yeah.
But how does that translate to, real-world benefits?
Well, what you end up with are parts that have minimal flaws, incredibly smooth surfaces, and exceptional dimensional accuracy. This is really critical for applications like, medical devices, where precision and sterility are non-negotiable.
Wow. So we've gone from simple gravity to this incredibly high-tech vacuum method. It's incredible how each technique has its own, strengths and purpose.
It really is. What I find, most interesting is how these methods, even the complex ones, impact our daily lives in ways we might not even realize.
That's true. It's easy to forget that all those, everyday objects we take for granted had to be made somehow.
Right. So the next time you, pick up your smartphone, drive your car, or even look at a piece of modern architecture, take a moment to consider how metal casting played a role in its creation.
That's a great point.
You might be surprised by what you discover.
I think you're right.